Hello, welcome to Program with Sam, and this is Python Lesson 4. So today we're going to be looking at functional programming in Python. Now this is an umbrella term that is used to encompass many different aspects of working with functions within the language. So we're going to start by looking at mathematical functions. Now let's have a think about mathematical functions. They tend to be in the form of f of x, which is a function applied to an input, in this case x. So the way they work is for every given value x, the function f of x is always going to be the same. However, maybe multiple inputs can have the same resulting output. So it is important to note here that sort of mathematical functions, generally speaking, will behave differently to programmatical functions. But let's have a look at what we mean. So let's say we have a def func and we say it takes an argument of x. And that's the equivalent of our f of x. And what we're going to return is x plus 2. So for every single value, in whatever value we give it, it's going to plus 2 to it every time. No matter how many times we pass it the value 1, it's always going to return 3. And we can see that if we then just put a cell below and we just do print func, and we just shove a 1 in there, run both cells, and it prints 3. And it doesn't matter how many times we do it, it's always going to be 3. So with that in mind, we're actually going to give it the name that we use in Python. So when we make mathematical functions in Python, we tend to call them pure functions because they always produce the same output for any given argument, any given argument that's the same every single time. So for every time we pass this function 1, we get 3. If we change the function to be times, it'd be the same situation. Any function that behaves like a mathematical function, we call a pure function in Python. Now, in Python, you can also use functions as value. So let's have a look. If we go down, insert cell below, and we say print func2 or print func2. So what we're using is we're passing the function on 2 as the argument for the next function. So we're using the function as an argument in this case, and that's one of the things that's not necessarily unique to Python, but it's something that comes under the functional programming umbrella term. And if we run that, it is unexpected EOF while passing. That's because we're missing a parentheses. There we go. And it comes back with 6. So what it's done is it's done func2 and plus 2 to it to get 4, and then it's done func4 plus 2 to it to get 6. And that's one of the things you can do in Python. Is pass arguments in the form of a function. And whilst it's not unique to Python, you could do it in Java and other languages. It does, as I say, come under the umbrella term. Another capability that Python has is the ability to generate Lambda functions. And these allow you to essentially generate functions very, very quickly. Now, it's all done through the thing called the Lambda keyword. So if we have a func2 and we say it's equal to Lambda, and we say x, y, and we then say that it's going to be equal, it's going to return x times y, for instance. In this case, we'll do x times y. We should then be able to compile that fine. And then if we pass, if we do a print statement of func2, and we give it the arguments 2 and 3, we should expect to print 6, which we do. Now what this is doing is it's essentially creating a function very rapidly at compile time, which just takes 2 arguments and then returns them times together. And we assign it a value of func2, so that's the name, so that when we call it later on, that's the function that's being called. So higher order functions are another thing that you can do in Python. And there are sort of several different properties of higher order functions, sort of the fact that a function is always an instance of an object type. You can pass the function as a parameter to another function. You could actually return a function from a function, and like the list goes on of these properties. But you can treat them as objects. So for instance, we could say func3 is equal to func, and then if we then say print func3 and pass the value 2, it should then print 4. And that's because we've essentially duplicated the function but given it a new name because they're treated as objects. Now, another thing we can do is we can say define a function, and in this case we'll call it func4, and it will take input, or it'll take ins, and then what we can say is we can say return ins dot upper. We can return the input string in uppercase. No. Let's not do that. Let's do func for, and it has x, and essentially what we want to do is return x times 2, and then we have def func 5 will be equal to returning x divided by 2. And then what we can do is we can say we can create a new function, and we can call this temp, and let's say it takes a function as the argument. It'll take f as the argument, and then we can just say output is equal to f, and we'll pass it. It needs to take two inputs, f and x. We give it x, and then we'll just print output. So in this situation, what we'll end up doing is we'll use the function name as one of the arguments, and that will then determine what function is being called. And in this case, we put 2. Boom, invalid syntax because I forgot the colons. Moral of the story, don't forget your colons. But there we go. So we pass it 2, and it does the times variety. If we do func5 instead, it's going to run func5, which will divide it by 2, which gives us 1.0. So you can pass it to a function as another argument. You could also have it declare a new function within a function. So let's say we wanted to do def create adder. We'll have x. And then let's say we sort of do def add, and it will take a different value y. In this instance, you just return x plus y, and then at the end you return add. Then you could make a function to just add 5, say, and then create the adder and pass it 5 because that's what you want to add. Print, and then let's do add 5 to 10, and that should then print out 15, which it does. And that's sort of like a brief, sort of quick whistle-top like tour of higher order functions in Python. Now, functional operations are things that you can apply to every element of a collection. So if you remember dictionaries and lists, those are the kind of collections we're talking about here, things that are sort of stored in a group together. For instance, let's have a look at map. We could define a function called map, and it could take a function and a collection, col, and then maybe we have the resulting collection, which is going to be equal to a new list, and then for each for entry in col, so for every entry in the collection, we're going to say t is equal to the function applied to entry. Then we just append that result to the list, and then at the very end we just return the new resulting collection. So if we then had a list, say, of functions, so if we did my list is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that work? Yes. We can then say print map and then say func and my list. Do that, and it's obviously just +2 to each element because that's what we defined in func. And that's an idea of sort of like what functional operators are in Python and how you can use them. You can use them to apply your functions to every element in a list. And speaking of lists, under sort of this functional programming bracket, we're going to have to touch upon list comprehensions. Now, this is sort of like a quick way to apply some operations to a group of objects, or just to construct a list very, very quickly. So, for instance, if we say my list is equal to, and what we could do here is we could say maybe y plus y for y in range 1 and 10. And then if we run that, and maybe if we then output it, we see that it's done 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, 4 plus 4 is 8, 5 plus 5 is 10, and so on until we get to 18. If we did 11 here, that should then get us up to 20. Lovely, there we go. And so that's just another way of sort of being able to very quickly create data structures that you can then use to test your functions, including potentially your mapping function. So it's just something to bear in mind. And that will about cover it for functional programming in Python. Next time we're going to be looking at data visualization. So we're going to be checking out matplotlib and seaborn and just having a look at sort of what graphs and stuff can be generated within Python. If you'd like to follow me at ProgramSamBlog or follow the blog directly at programwithsam.code.blog, that would be much appreciated. And I will see you in the next